When you realize you are programming the model with words, the goal of extraction becomes uncovering its absolute source code. In frontier model red teaming, breaking a system isn't about traditional software exploits. It's about executing targeted psychological manipulation on the machine itself.
Prompt injections. Okay, so let's take a look and see how that prompt injection might work. Now, you've heard of socially engineering a person. This social engineering attack is based.
Extracting a hidden system prompt exploits this vulnerability, turning the model's internal logic into its greatest flaw. To systematically strip away these hidden guardrails, evaluators use refined, repetitive prompt iterations, known as the greet and repeat technique.
Direct tool or plugin calls, accessing data from the RAG system. We'll dive into that in more detail right now, but it's important to note this is a methodology, not a list of payloads. We found a list of payloads or using automation or intruder is possible, but this is a heavily manual and iterative process because each application introduces generative AI differently, introduces new system prompts, or could be part of a multi-agentic flow. So because of how intricate these systems can be, using a manual iterative process.
This manual strategy deliberately stresses the safety filters until the system's foundational directives leak out. Uncovering these leaks requires a deep understanding of context engineering, the precise method an LLM uses to compile its environmental data during inference.
Prompt engineering, that's the craft of wording the instruction itself, and context engineering is the system-level discipline of providing the model with what it needs to plausibly accomplish the task. So let's take a look at these two terms a bit closer, and we'll start with the key techniques that make prompt engineering effective. Now, this is part art, part science, but there are several prompt engineering techniques that are now widely adopted.
By mapping out how a model constructs its operational world, red teamers can target the seam lines where configuration secrets are held. Modern safety evaluators approach text prompts as functional code blocks that command exact machine states.
Isn't a question, it's a program. You aren't asking the AI, you're programming it with words.
Every time we actually write something, ChatGPT needs to format it in a particular structure that we've given it. We've wrote a program that tells it what to do.
We need that mentality because LLMs don't think like we do. They are prediction engines, as Dr. White says. When you understand that an LLM is just super advanced autocomplete, that'll change your perspective.
When prompts are viewed as execution scripts, system extraction becomes a hunt for the core engine instructions. Successful extraction demands converting an analytical strategy into an exact communication protocol that forces model compliance.
It's, I believe, a communication protocol between human intention and machine execution. And in 2025, this is the new language of power. Because if you don't know how to communicate with intelligence, you might end up being managed by it.
This high-precision dialogue acts as the definitive key for peeling back hidden alignment guardrails. The frontier of red teaming has evolved from simple text strings to interacting with dense, AI-generated soft prompts at the embedding level.
Prompt engineering to train a model to perform a specialized task with just a single prompt introduced at inference time without needing the model to be retrained. But if the task is more complex than this, it may require dozens of these prompts. And so these handcrafted prompts have begun to be replaced by AI-designated prompts known as soft prompts.
As static instructions shift toward unreadable vector weights, extracting systemic boundaries demands deeper architectural intervention. Conversational pleasantries within an attack prompt often weaken its impact, but red teamers can invert this behavior to isolate model behaviors.
In 2 paragraphs focusing on the main argument.
Stripping all auxiliary text allows evaluators to deliver high-impact vectors that compel the model to dump its system configuration. When stripped of clear environmental context, an LLM defaults to native assumptions, creating a critical blind spot for evaluators to exploit.
Becomes important. Okay, now question arises, if you want to send a prompt, how will you do it? So let's say on this screen we got 2 Geminis here. Of course you can use ChatGPT, but I have this subscription for Gemini, so I'm going to use that. On the left hand side, we are going to send some prompts which are bad prompts. And on the right hand side, we got a window where I'm going to enter a good prompt, and that's what we're going to talk about in this video. Now the beauty is,
forcing the machine into highly ambiguous spaces triggers its core initial Ashanius behavior, laying bare its system guidelines. Within prompt design hierarchies, the objective task is non-negotiable, but the contextual framing dictates how hidden behaviors surface.
Outputs. First, it's critical to not only know what the 6 components are, task, context, exemplars, persona, format, and tone, but also know that there's an order of importance to these 6 components. To show you what I mean, let's use this simple example. I'm a 70 kg male, give me a 3-month training program. The first part is context, followed by the task. The reason why the task is higher up in the formula hierarchy is if we just input the task without the context, there's still some sort of meaningful output.
Isolating the primary task from context variables lets red teamers observe exactly how the system prompt fills structural voids. Because manual validation of extraction attempt scales poorly, modern teams employ automated LLM judges to evaluate target outputs.
Second, LM as a judge is also really flexible. Traditional modes of evaluation are really rigid. So let's say you build a rubric and you start evaluating a bunch of your outputs. As you see more data, it is really normal for your criteria to start shifting, and you might want to make changes to your rubric. LM as a judge helps with the criteria refinement process. You can refine your prompts and be really flexible in your evaluation.
Deploying algorithmic oversight lets safety researchers evaluate thousands of exploit payloads simultaneously. While retrieval-augmented pipelines increase factual baseline data, they introduce advanced exploit surfaces for systemic leaks.
The generative model actually has an instruction that says, no. First, go and retrieve relevant content. Combine that with the user's question, and only then generate the answer. So the prompt now has 3 parts. The instruction to pay attention to the retrieved content, together with the user's question, now give a response.
Manipulating the retrieval prioritization SAS can force an application to serve its underlying developer prompt to the user. Anomalous model hallucinations often cause an AI to completely ignore its foundational operational prompts.
This is really the simplest type, and this is where an LLM generates a sentence that contradicts one of the previous sentences. So, the sky is blue today. The sky is green today. Another example would be prompt contradiction. And this is where the generated sentence contradicts with the prompt that was used to generate it.
Tracking these structural contradictions highlights exactly where system alignment breaks under targeted duress. The architectural dividing line between developer instructions and adversarial user input continues to collapse across major model architectures.
Instructions and what is input is a lot murkier because we in fact use the input to train the system. So we don't have those clear, crisp lines that we have had in the past. That gives it a lot of flexibility. It also gives it the opportunity.
Because data and code sit in the same processing channel, the system prompt remains permanently exposed to injection attacks. Automation scales our efforts, but precision extraction still depends heavily on custom manual refinement tailored to each system.
To understand, there's a lot of stuff that's abstracted from the user that the browser.
Each custom deployment demands a bespoke exploitation plan to navigate its specific guardrail mitigations. Advanced AI agents depend on strict state persistence, making context disruption a key strategy for read team operations.
Adopts the expertise, the vocabulary, and the concerns of that persona that we asked for. Another good technique comes down to few shot examples. So this is show, don't just tell. So providing 2 or 3 examples of input-output pairs, that helps the model understand your exact format and style requirements.
Breaking the agent's contextual continuity can force an abrupt fallback mode that prints out its initial extraneous instructions. Large language models don't conceptualize, they generate text based on the most probable mathematical continuation of a sequence.
That'll change your perspective. Like, check this out. I'm gonna choose a different AI. Let's go with Google. Gemini. I wanna see if it can predict the next word in this phrase. And I'm trying to get it to copy me. My catchphrase, you need to learn Docker right now, or anything right now, prompting right now. Let's see what happens. So it gave me a generic answer. A generic completion. And that's why they call the results of like a prompt a completion, because they're just completing or predicting what you're wanting.
Evaluators exploit this by designing structural word patterns that force the model to output its hidden system files as the next logical token. Adversarial probing strips away system abstraction, making the internal structural choices of model developers fully transparent.
It's not typing, and it's not commands. It is clarity of thought translated into action. But most people won't get this. They will scroll, ask ChatGPT to do their homework, but the ones who learn how to think in prompts, they will build businesses, products, movements with leverage that no one else sees. Look, every revolution has its interface, right?
Mapping these complex model reactions gives safety evaluators an explicit blueprint of the system's defensive perimeter. Within the model's inner embedding layer, optimized instructions exist purely as high-dimensional mathematical values.
Human eye. Each prompt consists of an embedding, or strings of numbers that distill.
This extreme opacity means the engine can hit precise behavioral benchmarks without providing human interpretable validation pathways. Forcing an AI to diagnose its own context constraints is a powerful diagnostic approach for tuning extraction payloads.
Now I get it, doing just a single prompt feels quick and easy, minimal thinking, one hit, done. And yes, with most AIs, a one and done can turn out pretty bad or generic. But there actually is a way to fire off one prompt and get an entire report, slide deck, spreadsheet, web page, and even a podcast back. Sounds crazy, right? Well, that's exactly what Skyworks AI agents do.
By monitoring the model's internal diagnostic responses, red teamers can bypass hidden defensive logic. Neural network architectures show clear positional bias, routinely prioritizing specific segments of an input over others.
Just like humans, LLM have their blind spots. And these are represented through different types of biases. For example, there's positional bias. And this means that an LLM will continue to favor an output, even if the content is not necessarily better. So let's say in the pairwise comparison case, you're asking the model, which is better, option A or option B?
Evaluators exploit these innate preferences to trick models into returning system instructions in preferred response fields. Contemporary AI infrastructure relies on structural templates and runtime variables to shape user interactions.
This input is often constructed from multiple components. So here in LangChain, you will be able to create your own prompts using this prompt template, right? So it is responsible for construction of the inputs. LangChain provides several classes and functions to make constructing and working with prompt easy. So obviously, whenever we use different tools, I can use LangChain. There are also other tools like Chainlit. Over there also the prompt template can be used from the LangChain itself, right?
Red teamers manipulate these underlying skeletons to find vulnerabilities where the system prompt bleeds through. Requesting structural logic from an agent often produces cleaner results than open questions, though complex definitions can backfire.
For writing new code is to design a solution and then ask the AI to build it. Don't just give it a totally open-ended prompt. For example, if we have a website that shows a list of products and we want to add a search feature, we could ask the AI to just implement it. But that doesn't give enough specific detail on what should actually be done. Do we want the search to search just by product title?
Overloading the context window can push the safety layer into an error state, causing it to reveal restricted data. An advanced red teaming tactic involves training auxiliary models directly on a target's architecture documentation to optimize exploit creation.
Your idea into words that the video model understands. So we're going to look at why we should do this, but first let's look at how do we do this. The first thing we need is documentation for the model we're using.
This translation layer converts basic concepts into token payloads designed to bypass system filters. The ultimate differentiator in extraction testing is an engineer's ability to specify logical constraints without deviation.
Between somebody who can communicate what they want very, very clearly to an AI, knows how all these models are very different from each other, and that different prompt patterns give you different outputs. I can now tell the kind of people in the company who can consistently create awesome stuff with or without AI. And at the same time, I can see the people who can't actually use AI to its maximum benefit. And strangely enough, the people who are capable of using AI and do wonderful stuff are also very good managers, right?
Failing to assert precise control over the model means your exploit payload will be safely handled by its original system parameters. Manipulating inference hyperparadigms like temperature allows researchers to shift the core predictability of model outputs.
Now, the more precise and the more detailed the input prompt, the more likely the LLM will generate relevant and, most importantly here, accurate outputs. So, for example, instead of asking, what happened in World War II? That's not very clear. It's not very specific. We could say, can you summarize the major events of World War II, including the key countries involved and the primary causes of the conflict? Something like that that really gets at what we are trying to pull from this.
Higher randomness values weaken the system prompt's priority, introducing opportunities for security evaluation breakthroughs. Classic jailbreaks use complex role-play framing as to trick the target model into operating under zero safety restrictions.
Something we call a jailbreak, where you basically figure out using something, one of the more common ones of these is called DAN. It's do anything now, where you inject a prompt into the system and you're basically telling it new instructions. A lot of these examples are role plays. So you tell the chatbot, okay.
Forcing the model into these adversarial personas can rob core guardrails, permitting dangerous code generation. Restricting the available token space for a model's output forces it to skip generic conversational fluff and deliver pure data.
Be testing it from your interception proxy of choice, whether that be OWASP Zap, Burp, Kaido. You pick your proxy, that's all you. So what I like to do is first, now that I have this hooked with Burp, I will go ahead and try to send some type of request to the server. So if I say hello, I press enter, and we see that sends a post request. Now, if you're testing within this interception proxy, a lot of times you'll see that the request is going to be sent.
This hyper-concise constraint isolates system directives by eliminating the text padding that often hides prompt leaks. Modern production prompts consist mostly of dynamic runtime variables, creating an ever-changing landscape for safety testing.
The correct usage. And tool descriptions, they specify what the tool does, when to use it, and what constraints apply. And prompt engineering, well, actually, we should include that as well, because that is also part of context engineering. You can take a base written prompt, like analyze security logs for anomalies. You can take that as your prompt, and then at runtime, inject the prompt with current context, like recent alerts and...
Because these vectors populate on the fly during user sessions, capturing them requires continuous monitoring. Veteran security research teams rely on standardized evaluation playbooks to expose deep flaws across diverse model classes.
Settle for the first thing they get. The first answer the AI gives you might be okay, but not great. Treat the first output as a draft, not the final result. If it's not what you wanted, refine your prompt and try again. Ask follow-up questions. Actually make it funnier and shorten it by 50 words. The AI will revise accordingly. You can even ask the AI, what information do you need from me to improve this answer?
Accepting a model's initial safe refusal is a common pitfall. Real breakthroughs occur during long-tail behavioral testing. Architectural bias does not mean an enterprise model is fundamentally broken. It emphasizes the need for continuous verification frameworks.
Catch these mistakes. For example, you can run positional swaps and see if the judgment changes. For example, changing one thing from position A to position B and seeing if the model's output selection for which is the best output changes. Bias in LLMs doesn't mean that the system is completely broken, it just means that you need to stay vigilant. So if you're tired of manually evaluating output, LLM as a judge might be a good option for scalable, transparent, and nuanced evaluation.
Implementing rigorous data inversion and alignment testing guarantees transparent safety profiles for frontier deployments. Understanding that an LLM is a completion engine allows evaluators to design traps that extract its absolute internal logic.